Hello, this is the part 2 of hepatic clearance. So as I have mentioned earlier, you have to use this data of the healthy individual to calculate do the calculation for part 2 and 3. First, if you see in part 2, what is asking, the cimetidine drug inhibits metabolism of this drug, the above drug, and decreases the intrinsic clearance of free drug. This is the intrinsic clearance of free drug by 2.3-fold the original value. Excuse me. But this your Q FB remain unaffected, so then now it is asking to calculate the following kinetic parameter in the presence of cimetidine. So in other words, this question is asking you to do the calculate the kinetic parameter of this drug, which we have been calling kinetonol, in the presence of cimetidine. Because of the presence of cimetidine, cimetidine decrease the intrinsic clearance of free drug by 3.4-fold. Although Q, liver blood fraction unbound drug, remain unchanged. Now we have to calculate this parameter, hepatic extraction ratio, hepatic availability, and all other parameters. Now let's do those calculation. To calculate, we have to first calculate our new CLINT. So our original was what? Original was this. Original CLINT, what we have calculated earlier, is going to be CLINT is going to 42640.11 times 0.34. So it just decreased by this many fold. So here your new CLINT would be 14497.64. so your new CLINT, just you have to use this value in different calculation. Just remember, CLINT prime is 14497.64 milliliter per minute. This is our new CLINT. So just remember, this thing we have to use over and over. Now hepatic extraction ratio. Hepatic extraction ratio we can calculate by using this equation. If you remember, E is equal to CLINT divided by CLINT plus Q. But we don't have that CLINT. For this, we have to first calculate hepatic intrinsic clearance. This is, we have calculated intrinsic clearance of free drug. So hepatic intrinsic clearance would be CLINT is equal to 14497.64 milliliter per minute. Sorry, let's write the equation. Equation is this one. T times FUB. So this is intrinsic clearance of free drug. Now this is our intrinsic clearance, 14497.64, and FUB, if you remember, FUB is 0.83. This is our FUB, 0.83. Just multiply with 0.83, so it should give you a value of 12033.04 milliliter per minute. So this is our new intrinsic clearance. So this is in hepatic intrinsic clearance. As just to remember again, this is intrinsic clearance for free drug, and this one we are calling hepatic intrinsic clearance. So now in this new hepatic intrinsic clearance, we have to use in this equation to calculate extraction ratio. Now let's explain this. I hope you understood how to calculate hepatic intrinsic clearance. Hepatic intrinsic clearance, there is an equation, CLINT is equal to CLINT is prime times FUB. So you will figure what is the CLINT. So now we put it CLINT. We know that CLINT is 12033.04 divided by 12033.04 plus 1500, and we know that what is Q. Q has not changed, it is 1500 milliliter. Now your extraction ratio is 0.88916. So here your new extraction ratio is 0.88916. So there are multiple things we have to do to calculate this extraction ratio because CL and T has changed. First step we have to calculate as it has decreased by 3.44. what we have to do, we have to multiply the original one, which is this one. We have to multiply original times 0.34. This will give you a new CL prime INT, and then this CL INT you use to calculate CL, this one, to calculate CLINT is equal to, we know, CLINT prime times FUB. So this will give you new CLINT. When you have the new CLINT, you just use that equation. E is equal to CLINT divided by CLINT plus Q, and this will give you a new. And once you know this extraction ratio, then other things are easy. Then now it is asking you to calculate hepatic availability. We know hepatic availability, F prime is equal to 1 minus E. This is going to be, what is going to be 1 minus 0.88916 is equal to 0.1104. So this is going to be your hepatic availability, 0.11084. If you know the hepatic availability, and we have to calculate also some other parameter, which is oral bioavailability. Oral bioavailability we can calculate by using F, and we have to use that previous FG. There was no change in Fg, so you have to use this is our Fg 0 point, so we have to use previous Fg. So we know the equation for oral bioavailability is F is equal to Fg times F prime, and we are going to use our old this one, which was 0.735 Fg. So 0.735 times 0.11084, which is going to be 0.08151. So oral, this is going to be oral bioavailability, which is 0.08151. And now hepatic clearance. Hepatic clearance we have to calculate. We know that CLH, for this CLH is equal to Q times E. We know Q has not changed, which is 1500, and we know what is the new E. New E is this one, 0.88916. This would be this would be 1333.74 milliliter per minute. You see this hepatic clearance here, our hepatic clearance, previous hepatic clearance, it has decreased. You see here 14, and here it has decreased a little bit. So our new hepatic clearance is this one. Our new hepatic clearance 1333.74 milliliter per minute. Now we have to calculate total clearance. How do you calculate total clearance? Which is renal clearance has not been changed. Renal clearance has not changed. So CL is equal to CLH plus CLR. So our CLH is what? 1333.74 plus our, this is here, renal clearance has not changed. Let's go back to renal clearance. What is the renal clearance here? 330.99. This is our renal clearance. So 330.99, this will give you a new total clearance 664.73. So this is your total clearance. This is your total clearance, 1664.74 milliliter per minute. If you go back to the total clearance, what was the total clearance? You see, it has gone down because of the interaction of, because cimetidine inhibits the metabolism of this, that's why its clearance has gone down. And then elimination half-life, which is easy. Elimination half-life, I have to use all of this equation to calculate elimination half-life. T half is equal to 0.693 times V divided by CL. We already know what is CL. I think this is our CL, new CL. The CL means total clearance. So, and we have our volume is in liter, I guess. Yes, volume is in liter, So we have to do some conversion of unit here. So CL, we have CL, which is 1664.73 times 1000 divided by 60. This will give you liter per hour, which is I think 99.88 liter per hour. So we have CL. Now T half is equal to 0.693 divided by multiplied by 253, which is V here, 253, which is 253. Let's see again. Six nine three times 253 divided by 9.88 is equal to 1.7553 hour. So this is how you calculate half-life. So our half-life here is 1.7553 hour, and our clearance is this. So these are the calculations for when intrinsic clearance decreases. Now another situation here you will see in the second part of this. We have now normal, there is no change in intrinsic clearance. What is happening? Decreased, so liver blood flow decreased. So all this problem set is trying to explain the first one, everything is normal, how you calculate different kinetic parameter. Here what is happening, an interactive drug, and this is an interactive drug decreasing the metabolism of the another drug. So cimetidine decreasing. What changes it causes to the clearance of hepatic clearance because of the presence of this second drug. So we have to do this calculation in the presence of an interacting drug. Now everything is normal except that patient has a bad liver. So what are the changes we have to do? What are the calculation we have to do? Only thing, you see here it has changed. Our normal liver blood flow was 1.5 liter per minute, and we have that normalcy. Only thing has a change. Now what are the how metabolism is going to change? So this is the entire goal. So now first we have to calculate hepatic extraction ratio. We use that hepatic extraction ratios, the same equation, E is equal to CLINT divided by Q plus CLINT. Okay, so now we know that normal CLINT, if you go back, don't lose those data, normal CLINT, our normal CLINT was this one. I've done a better job. So 3539. So this is our normal CL. This is the one you have to use here to calculate CLINT. So here we use our normal CLINT 3539.1.29. Q has changed, 12 milliliter per minute plus 35391.29. So our hepatic extraction ratio, new extraction ratio should be 0.9672. So here I think rest of them are going to be very easy once you know this calculation. So we have our new hepatic extraction ratio is 0.9672. Now hepatic availability, same old story. Now F prime is equal to 1 minus E is going to be 1 minus 0.9672 is equal to 0.0328. It is your hepatic extra availability. Same, now it is just repetition of old stuff. 0.0328 to be hepatic availability. Oral bioavailability, same old thing. F is equal to Fg times F prime. We know Fg is the old Fg before because there was no change in GI availability. 0.735 times F prime is 0.0328 is going to be 0.0241. So our availability is 0.0241 is your oral availability. Same thing, the hepatic clearance. Hepatic clearance, we know this equation CLHQ times E. So what has changed here? It has changed Q. We have a new Q which is 1200 milliliter per minute times E is this one, new E. So here everything, we have an extraction ratio new and we have a clearance, new hepatic extraction ratio and a new volume of blood flow rate 0.9672. This will give you I think this is 60.65. So you just multiply, I think it is 1160 or 50. Let's go back to my calculator. 1200 times 0.9672. Yes, what is 1160.65. So here is your hepatic clearance. Hepatic clearance is hepatic clearance is 1160.65 milliliter per minute. Okay, so here we have two total clearance. It's very easy, you just add those things. Your hepatic clearance, total clearance is CLH plus CLR. We did not see any change in the CLR, renal clearance. So here you have put 1160.65 plus CLR is 33, and this is going to give you total clearance. Total clearance would be 149.64 milliliter per minute. And now elimination half-life, the same way as you have calculated in part 2. T half is equal to 0.693 V divided by CL, and you have to convert CL to liter per hour. Our CL, new CL is 1491.64, which if you convert to liter hour it would be 89.498 liter per hour. So now T half would be, it doesn't change, the volume distribution 0.693 times 253 divided by 89.498. is equal to 1.959 hour. So with this I'm done with this assignment videos, but is asking the please prepare a table comparing all the stuffs, intrinsic clearance of free drug, fraction unbound, and then intrinsic clearance, how it changes, so that you will have an idea that how blood flow and drug property changes the metabolism of a drug. So again, to summarize everything together, let's clean this first. So this assignment has a point to make, so that a student understand this what's going on. First one in first part, and this will also help you to understand or answer question related to concept question. So first, this part we are talking about everything normal. So you have to do some calculation of a normal individual. So now here it is talking about when one drug, an interactive drug, inhibits the metabolism, then how it changes the extraction ratio, hepatic availability, everything related to hepatic availability, hepatic clearance, and at the end how it changes the total clearance. So that means anything that affects metabolism of the drug will affect the hepatic clearance. Here it is showing that when blood flow changes, renal blood flow changes, liver blood flow changes, how it is going to affect the hepatic clearance. As you can, if you compare with all this data here, that for example our hepatic clearance in this case was 1160.65 milliliter per minute. If you go back to our earlier than the question number 1, what was the hepatic clearance? Our hepatic clearance was 1439.01. This was our normal individual hepatic clearance. And then if you go to the second part 2, our hepatic clearance was second part. Our hepatic clearance was, I think, 13.74 milliliter per minute. And then when the more profound influence was on change the blood flow, and one of the reasons is change the blood flow, it is because it is a high extraction drug. I will explain this concept over and over in the class, but with this I am done with the assignment video. I hope it helps.